Hi guys, this is Miss Eisencraft. Today we're going to go over how to convert between radians and degrees. I'm going to split this up into two videos. So the first one will just be from radians to degrees. And then on the second video, we'll go back from degrees to radians, but using the same document. So when we talk about radians and degrees, we need to remember they're just two different ways to measure angles. So the big idea here is that 180 degrees is equal to pi radians. And if it's helpful to have a circle, I know it is to me, to kind of think of some of those anchor points. If we think of degrees, this is 0 degrees, 90 degrees, 180 degrees, 270, and 360. Okay. And another, if you think of radians, we can call this 0 radians, pi halves radians, pi radians, 3 halves pi radians, and 2 pi radians. So those are just some nice ones to kind of keep in your head. And I'm going to teach, there's a couple different ways to think about it, but one of the simplest ways is to, when you're converting between any kind of units, is to use a conversion factor. And so if we have 180 degrees, and that's equal to pi radians, we can either use the conversion factor, depending on which unit we're starting with and which one we want, 180 degrees over pi radians. That's one of the conversion factors we'll be using. Or there's pi radians, we're saying the same thing, in 180 degrees. And these conversion factors both really just equal 1, because 180 degrees is equal to pi radians is equal to 180 degrees. And so when you're multiplying, something that you're given to try to get to another unit, it is, mathematically legal to multiply any number by 1 and get without changing its value. You're just changing the unit name. So that's the idea of conversion factors. A lot of kids, I think we do it in science. So that's how we're going to apply it here. Okay, so when we're converting from radians to degrees, let's start with kind of an easy one. Okay. If we had 3 pi over 2, I tried to do one that we already at first to see, okay, is this already on our circle that I know? Okay, 3 halves pi radians. Ooh, that looks like it's 270. Let's see what conversion factor we could use, to mathematically get there without just looking. So from radians degrees, the way conversion factors work is this is given in radians, and we want to go to degrees. Okay, so if we want to go from radians to degrees, when you use a conversion factor, the conversion factor you choose is the unit that you are wanting in the end. You need that in the numerator. So we want to multiply by 180 degrees over pi radians. So that's what we're always going to do when we want to get from radians to degrees. We're always going to multiply by 180 degrees in pi radians. And again, you can ignore, as we do this, you can ignore the units later and just do multiply by 180 over pi. But I'm just trying to explain where the conversion factor, how it works or why it works. So we're just going to take 3 pi over 2 and multiply it by 180 over pi. And I want to end in degrees. So this is really degrees. There's really the word radians here and the word radians here. So the radians cancel out, the word radians. Also, pi is in the numerator and denominator. That cancels out. So now we just have to do this math. It is a fraction, so we're going to multiply across the top and across the bottom. You could cross cancel or cross reduce before to simplify, but 180 times 3 is 540. And 2 times 1 is just 2. We divide that out. We are going to get 270. And we don't want pi. Pi is canceled out. We just want degrees, 270 degrees. So I would write it at the end. This helps my brain. 3 pi over 2 radians is equal to 270 degrees. That was the conversion we did. Okay. All right. And that was one we also could have seen here. I was just trying to show you an easy one that we knew. Okay, let's try a little bit more difficult one that might not be on our circle. So what if we had 2 pi over 5 radians, and we want to convert that to degrees? Okay, so again, anytime we're converting from radians to degrees, we multiply by 180 degrees over pi radians. So we're going to have 2 pi over 5 times 180 over pi radians. So the pi's cancel out, and we're going to have 360 over 5. And this is going to be degrees. And it works out nice. 72 degrees. Okie dokie. Pretty easy, right? Okay, so let's write that. So 2 pi fifths radians is equal to 72 degrees. Those are the same spot on the circle. Okay. Third one. Let's do one that's past 360 or past the full rotation. So if I have 8/3 pi, you might recognize that that's more than a full rotation because 2 pi is a full rotation. So that would be 6/3, and 8/3 is more than 6/3. Or you might just look at it and go, whatever. Okay, so 8/3 pi, if I want to change that to degrees, and again, when they put pi off to the side here, you can just put it up here with the numerator. Okay, so we're going to multiply. We want to end in degrees, so we're going to multiply by 180 degrees over pi radians. I'm not writing the word radians every time. Okay, pi's cancel out, denominator, numerator. Here, cross-canceling might be helpful. You don't have to, but cross-canceling, I know that 3 and 180 can be simplified, so that might be easier for me. If you have no idea, what is she doing? You can skip the cross-canceling. So 3 goes into 18, so that'd be 60, right? So then we just have 60 times 80, and 8 times 6 is 40. So 480 degrees. That's more than a full rotation. 8/3 pi, or 8 pi over 3, is 480 degrees. Okay, and you can always come back up here and see, does that make sense? Like, you know, use this as sort of a tool. Like, does it make sense that this is the same spot on the circle as this? Okay, last one is a little weird. In all these other examples, the radians have been expressed in terms of pi, right? Like, so pi wasn't multiplied out to keep it exact. Well, sometimes radians can be expressed as like a decimal. So they already multiplied out pi. And of course they had to approximate, excuse me. But if they gave you something like, okay, I have 2.25, and they don't have pi, but they have the word radians. And they are asking, how many degrees is that? They didn't forget pi, they already multiplied it out. So we're going to do the same thing here. We want to end in degrees, so we're still going to take 2.25 radians. I'll just write radians. And we're going to multiply it by the conversion factor. There's 180 degrees in every pi radians. Okay. Now, the word radian canceled out. That's just the unit. The conversion factors work that way. It helps you know what to multiply or divide by. So now if this is a fraction, we think of it as a fraction. We just multiply across the top and across the bottom. But because they've already multiplied out pi and we couldn't cancel it out here, we're going to either use the pi button or 3.14 as an approximation and multiply this out. So I'm going to take 2.25 times 180, 5, divided by pi. And we're going to, we're not leaving it in terms of pi, we're going to divide it out. So I'm going to take 405 and divide it by, you can either use 3.14 or the pi button, or 405 divided by 3.14, 128. This is more exact, 128.9. If anybody got, it's around 129 degrees, no matter how, if you round it off to the nearest whole degree. So we'll just do that, which is about 129 degrees. So 2.25 radians is equal to 129 degrees. Okay. All right. So I'll be back with how to convert from degrees to radians in my next video.